Hello grade 11s and welcome to your trigonometry session. We are going to be looking at the overview for trig in grade 11 and then I'm going to take you through a few questions that generally pops up in your exams. So let's look at the overview for trigonometry. We basically get three kinds of questions in trig. We get questions where they ask you to simplify, and when you have to simplify trigonometry, usually you will use special angles and reduction formula to do that. Then your second kind of question, Pythagoras questions. They love asking Pythagoras questions. Here they normally want you to construct your own diagram and from the diagram simplify the trigonometry. Then the third kind of question, identities, and the fourth one, general solution. And we will be looking at all four of these kinds of sums. Right, but before we start, I just quickly want to go through the basics of trigonometry, just so that we can have a good recap on everything. Firstly, you need to know the ratios very, very well. Sine theta, you need to know that that is y over r. Cos theta, you need to know that that is x over r, and tan theta is always y over x. Now, I don't know how you remember it. You need to study this, make a little rhyme for yourself to remember it. It's not given on the formula sheet, so you need to know it very well. Then, going to the cast diagram, I always call it cast, and I put my cast, my C, A, S, and T into the specific quadrant so that I know what ratio is positive where. If you look at the first quadrant, that's why it's A, all the trig ratios is positive in that specific quadrant. Then in the second one, sine is positive. In the third one, tan is positive. And in the fourth one, I have cos that is positive. We also have certain names for that specific quadrant. Quadrant 1 we call the theta quadrant. Quadrant 2 we call the 180 minus theta quadrant. Quadrant 3, 180 plus theta. And quadrant 4, 360 minus theta. Then we also use cofunctions, and you will see that quite often, where we use a 90 minus theta and a 90 plus theta. You just need to remember that the 90 minus theta, you are talking about the first quadrant, and if you see a 90 plus theta, that is the second quadrant. Unfortunately, you won't get the cast diagram on your formula sheet, so you need to study that very well. You need to know all the properties off by heart. Right, then in grade 11, we give you two identities to study. We give you cos squared theta plus sine squared theta equals to 1. And then tan theta is also the same as saying sine theta over cos theta. And you will interchange between these two all the time. Just another format that they love asking this in, they sometimes want you to change sine squared theta into 1 minus cos squared theta. It's exactly the same as that one, it's just written in another form. Okay. Same here, they can also ask cos squared theta, which is 1 minus sine squared theta. Okay, so just know that you can interchange like that as well. Then special angles. Okay, if you use special angles, I'm talking about 45 degrees, 30 degrees, 60 degrees. If you see special angles, you can use your calculator. But we normally teach it with special triangles, and then you don't have to use your calculator, and then you can get the ratio straight from your triangles that you draw. The first special triangle that we use is the 45-45 one, and we have 1, 1, square root 2 then on your hypotenuse. And your second triangle is where you have the 30 and the 60. I normally draw it the other way around. I put the 60 there and the 30 there, Because if you go draw in your ratios, it's in a clockwise position. 1, 2, 3. So you go around the triangle, and your 3 always gets a square root 3 in. If you look at this one, that's anti-clockwise, so that's a bit confusing. So if you'd like to do that, rather write the 60 in the lower corner, the 30 upstairs, and then 1, 2, 3 clockwise around your triangle. Right, then you also get another way of remembering your special ratios for your special angles is also to use the unit circle. Also a very easy way to remember it. You start off by saying 1, 2, 3, 4, and you will take the square root of all of them. If you take the square root of 4, you get 2, 0. So you start there, you start off by saying, right, on that 90-degree point, I have an x of 0, 1, 2, 3, 4. So you go down the number line and you take the square root of all of them and simplify. And then to get to your y values, you start on the x-axis, 0, 1, 2, 3, 4. It's just another way of remembering it. You can decide which one you want to use in the exam. Right. Then, a few tips for proving identities. Number 1, change all into sine and cos. Let's say, for instance, you have a tangent somewhere, tan theta. And the rest of your ratios in your trig identity is all sine and cos. Try and change everything to sine and cos so that you can start simplifying quickly. Then, do not cancel over a plus and minus. What I mean here is when you have something like sine theta plus cos theta over sine theta minus cos theta. A lot of you want to start doing this. It's the same. So one is at the top, one is at the bottom. Let's start cancelling out. Please don't do that. It's a very, very big mistake because you have two terms at the top and at the bottom. You can never, ever cancel out trig ratios if you have more than one term at the top or at the bottom. And that's what I mean there. Don't cancel out when you have a plus and a minus. Then number 3, remember a common denominator. When you have two fractions in trigonometry, or in algebra for that matter, and you are adding or subtracting two fractions, we want to see an LCD. You need to show us the lowest common denominator, and you need to know how to work with that lowest common denominator and simplify the fraction. It's exactly like in algebra. Now we're not using x's and y's, but we're using sine and coses. So please check that you know exactly how that works. Okay, then point number 4, use square identities if you can. What I mean here is, I've just mentioned it though, they can ask it like this, the square identity, or they can ask you to substitute this instead of cos squared theta. So you need to know how to interchange between the square identity given. Then number 5, keep looking at your right-hand side, and that is a brilliant tip to give. When you decide to start with your left-hand side and you are simplifying your left, because normally you need to prove that the left-hand side is equal to the right-hand side. So then you guys start simplifying the left-hand side, and then you get stuck or you start substituting weird stuff in there. My tip is keep your eyes on the right-hand side. The right-hand side will guide you to where to go. It will guide your steps on the left-hand side. So don't forget to look constantly to your right-hand side. Then tips for general solution. For general solution, I call general solution sums Kes sums. And that, for me, is just to remember, I need to add k elements of integers. Because if you forget that, you miss out on a mark. Okay. So, general solution, Kes sums. Then, my first step there is also isolate the sine and cos or tan. When you have a general solution, let's say, for instance, you have 3 cos theta equal to 1. When you want to do the general solution, you need the trig ratio isolated or alone on the left-hand side. No coefficients, no squares, just the trig ratio. So before I can even start getting a reference angle, I need to divide by 3 so that I can isolate my trig ratio on the left and have only a value on the right-hand side. When it looks like that, then you can start by getting the reference angle. Okay, very important. Then, I just try to make this short and sweet for you here. If you want to get to the reference angle, so if I give you cos A equal to B, to get to the reference angle, you will normally type into your calculator shift or second function, shift cos B, and you will press your equal sign. And that will give you your reference angle. And when you have to go write down the reference angle in your specific quadrants, you will check in which quadrant cos is positive, which is the first and in the fourth one. And this one here is the first and fourth one together, where you say the reference angle plus minus K 360. Okay, but we will go through the examples where I will explain this quite nicely. Then for sine, if I give you a sine ratio, again to get the reference angle, you will type in shift sine D equal. And then you will check where is sine positive on the cos diagram, in the first and in the second quadrant. That's why I have here the reference angle plus K 360 for the first quadrant. It's just theta. And here you have 180 minus your reference angle plus K 360. And then in the tangents case, again you will type in shift tan A equals for your reference angle. And then very important to remember, when you write down the general solution for tan, it's always K 180, because the period for a tangent graph is 180 degrees and not 360. So important to remember that. Right, let's start with the first example so that we can kind of make sense of what I was just talking about. Number 1 says, show that cos 360 degrees minus x times tan squared x over sine x minus 180 cos 90 plus x is equal to 1 over cos x. So I need to basically prove here that the left is equal to the right. Another tip that I can give you is start with the more complex side. You can't start simplifying 1 over cos x because that's basically in its simplest form. So you will start writing down the left-hand side, and we will start working with that. The left-hand side we have cos 360 minus x and tan squared x over sine x minus 180 and cos 90 plus x. Now if you look at this sum, they basically give you reduction formula here. So you need to go look at the reduction formula, go check in your cos diagram and check the signs to simplify it. So let's look at the first one. Cos 360 minus x. Now you quickly draw up your cos diagram. I know that 360 minus x is the fourth quadrant. And now I go ask myself, is cos positive or negative in the fourth quadrant? It's positive. So my answer is just cos x. I reduce the angle and my answer is just x, or whatever angle they have in that space. Then I can't simplify tan squared x, that is already in its simplest form. Sine x minus 180. Now be careful. When they swap the two around, because we are normally used to using the number minus the angle. If you look at the quadrants, let me show you quickly. You have theta there, you have 180 minus theta and 180 plus theta. As soon as they swap them around, in this case, now they put the theta or the angle in front, x minus 180. that is an indication of a negative angle. And whenever you see a negative angle, please just add 360 to it. That's the easiest way to simplify it. So if you add, I'm going to take another color here. If you add 360 to x minus 180, what do you get? You get sine 180 plus x, positive 180 plus x. 360 minus 180 is positive 180. So that changes now to a positive 180 plus x. Then, let me just go on here. We have cos 90 plus x. Whenever you see a 90, that must trigger something in your brain. Yes, it's co-functions. Sine changes to cos, cos changes to sine. Here we have cos, so now this becomes sine, and 90 plus x is in the second quadrant, so we need to check the sign there. Is sine positive? Is cos positive or negative in the second quadrant? It's negative, so we add a negative when we change it, and we have x there. Right, we're not done yet. We still need to simplify this positive angle at the bottom, so we keep everything the same. Sine 180 plus x, 180 plus theta is in the third quadrant, and I know that sine is definitely negative there, so this will become negative sine x times negative sine x. Right, let's go on. I have cos x, and I say to you, try and change all your ratios to sine and cos. Luckily, they gave me a term, so I can change that to sine x over cos x, but be careful, it's squared. So you need to put that in. And here at the bottom, you get minus sine x times minus sine x. I have cos x over 1 at the top. There I have another fraction, so I have one term there, so I can start cancelling out. 1 cos x cancels out with one of those, so I have left sine squared x over cos x divided by, and I'm going to multiply these two now, so the minus cancels out and you get sine squared x. Now if you look at that, that looks quite confusing. And I would suggest that you now change the division line into a division sign to make it better to work with. So you keep the top fraction the same, sine squared x over cos x, divided by sine squared x over 1. That looks much easier. And all you want to do now is times and tip. And when you do that, I have the sine squared x's cancelling out, and your final answer, 1 over cos x. Just go back and check, is that the answer that they're looking for? Yes, it is. And I have the left equal to the right. And there's my answer. Let's go to the next question. Right, question number 1.2. Hence. What does that mean? Hence. I know a lot of you freak out when you see that word hence. Please just relax. Hence means use the answer of your previous sum to do the sum that they want you to do now. So they say here, calculate without the use of a calculator the value of cos 330 tan squared 30. Then they give a negative angle and 120. Now, if you go and simplify this, if you use reduction formula on this, you will see that the smallest angle that comes out here is 30. The angle that they use here is 30. I'm just going to go back to this question here. I had here cos 360 minus x, and then again x, and I had an x there and an x there. So it's the same x in every single ratio. The same angle is being used. Now when I go back to this one, tan squared 30, there's the angle. That actually gave me x is 30. Now you are going to use the answer of the previous one, which was 1 over cos x. I know that that whole thing will simplify to 1 over cos x. That's what I've just done it in the previous sum. But I also know that x is 30. So I substitute that in. How do I know cos is 30? Because there it jumps out. It jumps out. They're actually giving 30 there. And then all you do is you are going to use your special triangle. You have 60 and 30, 1, 2, square root 3. I know that cos is x over r, and your focus is on 30, so it's x over r. That makes it square root 3 over 2, and you want to swap that around, so your answer here is 2 over square root 3. Very nice question. Please don't get scared if you see the word hence. It's actually quite easy because you just got the answer in the previous sum, so just use it in the next one. Let's go on with the next question. 1.3. Simplify without using a calculator. Cos squared 180 plus x, so I already see reduction formula here, minus tan 360 minus x, 90 minus x, I see a cofunction, 90 minus x, another cofunction, and a special angle 180. So let's start simplifying. 180 plus x. Very important to have your brackets right here. Don't leave any brackets out because it will make a difference to the answer. Minus sine 90 minus x and cos 180. Okay, and your square bracket in. Okay, let's start with my first one. I have 180 plus x there. So I quickly draw up my cast diagram. 180 plus is in the third quadrant. Is cos positive or negative there? Definitely negative. But that square tells me it's twice negative. So it's negative cos, which means that changes to positive cos squared x. The minuses cancel out. 360 minus x, that's in the fourth quadrant. And I know that tan is negative in that quadrant, so I have to add a negative. And a negative times a negative, well, that's a positive, but let's keep it like that for now. 90 minus x, I know that is in the first quadrant. I know this is also a cofunction. Cofunctions, cos change to sine, sine change to cos. So this cos will change to sine x. Then you have minus sine 90 minus x. Again, now that will change to cos x. That minus is that minus. And cos 180. Cos 180 is a special angle. Now you can either use your calculator to get to that value, or you can use the unit circle. I'm quickly going to use my calculator. We have cos 180 equals, and I get negative 1, so negative 1 goes into that space, and you close it with your square bracket. Right, let's go on and simplify further. I have cos squared x there on the left-hand side, positive tan x, which is also the same as saying sine x over cos x, times sine x, minus and a minus becomes a positive, cos x. I'm going to multiply these two at the top, and then I'm going to get sine squared x at the top over cos x plus my cos x. And here you need to be very careful what you are doing, because now you have two terms that are added to one another, and the one is a fraction. So how do we simplify adding and subtracting fractions in algebra? Well, we get the LCD, and you need to do exactly the same in trigonometry. So if I go on here, keep the cos squared x outside, and I have cos x at the bottom here, and sine squared x plus cos squared x. Let me just quickly run through this with you. I have a cos x there, so I don't need anything in my denominator here to make it look like that one. So my top stays the same, sine squared x. Here I have cos x over 1. So I need to multiply 1 by cos x, but if I multiply 1 by cos x, I have to multiply the top with cos x as well. That's why I get cos squared x at the top. We're almost done here. This must tell you identity. So instead of writing sine squared x plus cos squared x, you're going to write 1 over cos x. That's a square identity. And I have 2 cos x's at the top, 1 cos x at the bottom. So those ones cancels out, and I get cos x. So everything's simplified just to one trig ratio, cos x. Beautiful question. Let's go on to the next one. 1.4. Show how you can demonstrate that the value of tan 300, I'm just going to write this next to one another, is equal to minus the square root of 3 without using a calculator. Now, if you get something like this, you are basically going to use reduction formula. You're going to take that obtuse big angle and you're going to simplify, simplify, simplify until you get to the smallest angle that you can use. So let's start by playing with tan 300. Cast diagram. Now I need to know, where will this angle lie? In which quadrant does the angle 300 lie? Now if I measure the angle, and I always measure from my 0x axis, I measure around, then I'm at 270, and then somewhere there, that angle will end. So that 300 angle will definitely lie in the 4th quadrant. And I know that tan is negative in the 4th quadrant. So my answer here, let's just first use reduction formula. I know that that is 360 minus theta. So I'm going to write there 360 minus what will give me 300? And that is 60. I know that tan is negative there, so I have negative tan, and my acute angle is 60. So I basically reduce that 300 angle to an acute 60 angle. And I'm almost done. And this is brilliant because 60 is a special angle. So immediately you draw up your magic triangle. You have 60 at the bottom, 30 at the top, 1, 2, square root 3. I know that tan is y over x, and my y in this case, if you focus on 60, my y is square root 3 and my x is 1. So my answer, square root 3 over 1, which gives me an answer of negative square root 3. And is that what they wanted? Yes. So we got to the answer. Remember, if they give you big angles, you have to use reduction formula to reduce that big angle to an acute one. And then from the acute one, it will normally be a special angle that you can use ratios for. Right. Then example questions 1.5. Simplify as far as possible. I have tan minus theta, sine 90 minus theta, 90, we know that's cofunction, so that's already in my head. 180 plus, it's definitely reduction formula, and 180 minus, again reduction formula, and there I have a negative angle. Right, let's start. I draw up my cos diagram because I have to check my signs. Tan minus theta. Minus theta. Theta is actually seen as an acute angle. But as soon as you add a negative, then you are measuring clockwise around your cos diagram. So we normally start measuring an angle from your 0 x-axis line. And when we have positive angles, we go anti-clockwise. But as soon as we have a negative angle, we will go clockwise. And because it's theta, it's still an acute angle. So that minus theta will lie in the 4th quadrant somewhere. And I know that tan is definitely negative in the 4th quadrant. So this simplifies to minus tan theta. Then sine 90 minus theta, I know that 90 minus is in the 1st quadrant, and sine and cos and tan is positive in the 1st quadrant. So sine, remember, changes to cos, and theta, no negatives. 180 plus theta, 180 plus is in the 3rd quadrant, and I know that sine is negative in the 3rd quadrant, negative sine theta. 180 minus theta, 180 minus is in the 2nd quadrant, and sine is positive there, so that will just change to sine theta. So now I used my reduction formula and I reduced it as far as possible. Now I can start simplifying. Maybe cancel out across the fraction. Let's see. Okay, I can't cancel out because I have that plus. Very important, you cannot cancel out if you have more than one term at the top or at the bottom. The only thing that I can do here is to start changing the tan to sine over cos. So let's try and do that. I have minus sine theta over cos theta times cos theta. Remember that cos theta is at the top over 1. And this is quite interesting. They say here minus sine theta plus 3 sine theta. It's the same as saying minus 1 apple plus 3 apples. So you are basically adding and subtracting like terms there. Because if I change the sign to an x, then I have minus x plus 3x. And that's quite easy, you get 2x. So that is exactly the same. So you get plus 2 sine theta, which is left. At the top there, you have a very nice 2 fractions that are multiplied. So it's cos over cos, so that cancels out. And at the top, you have left minus sine theta divided by 2 sine theta. You can cancel out because you have 1 term over 1 term. So sine over sine, there's nothing left at the top. But if there's nothing, there's actually a 1. And your answer, minus a half. Very nice answer. It simplifies to a very neat answer there. Great, let's move on to the next question. Simplify as far as possible 3 plus 2 cos squared b plus 2 sine squared b. Now, this one is actually quite tricky. If you can't see it, then you are going to struggle with this one because there's nothing that you have to prove left equal to right. You just need to take that expression and simplify it. So we need to look for something that we can simplify. Now that, for me, is a trigger. That gives me an idea. Cos squared b plus sine squared b. That reminds me of my identity, which is cos squared b plus sine squared b must give me 1. The only thing that bothers me here is that coefficient of 2 there at the front. But that's easy to get rid of. Since both of these terms have a coefficient of 2, we can just take that out as a highest common factor. So, we keep 3 there. We take 2 out as a highest common factor. We have left cos squared beta plus sine squared beta. And we know that that whole bracket will simplify to 1, and 3 plus 2 is 5. And that's definitely the simplest answer that you can get there. Very nice question. Right, we are moving to question 2 now. So all of question 1 was just simplifying, using the reduction formula, using special angles, using your special triangles. So that was all just simplifying. Question 2 will now move to calculator work. So let's see at what they ask here. They say that x is 21,1 and y is 47,5. Calculate correct to 2 decimal places. That tells you I'm definitely going to use my calculator here. Calculate the value of cos 2x. So what I want to do in my calculator is say cos, bracket, very important. When you are manipulating or changing the angle in any way and you want to use your calculator, you have to put in brackets. Otherwise the calculator will not give you the right answer. So brackets 2 times x, and x is 21,1. So I'm going to use my calculator here and quickly get to that answer. I have cos 2 times 21,1 and close the bracket. Answer there 0,74. Let me just check if I did it. Yes. 0,74, that's 2 decimals, so that's fine. Okay. Moving on, 2.2. Find the value of sine y minus 2x. Right. Now I start substituting quickly. Sine, and my y is 47,5 degrees, and my x is 21,1. As you wrote it down there, you will exactly type it in like that in your calculator. We have sine bracket 47.5 minus 2 times 21.1 and close the bracket and press your equal sign. So your answer 0.09, and the 2 will not change the 9, so it's just 0.09, and I'm going to write that in. And there's your answer. Then going to the last one for calculator work, 2.3. Find the value of the square root of tan. My y is 47.5 plus tan 47.5, and I'm going to put that in a square. Okay, and you're going to put that exactly like that into the calculator. So let's try and do that quickly. We have square root tan 47.5 plus tan 47.5 and close the bracket and square it equals to 1.51, and that is basically my answer, 1.51. Fantastic. Calculated work is actually quite easy. If you know the brackets, then you are well away and you can't really get anything wrong there. So just remember the brackets and to put it in exactly as you write it down. Right, going to question 3. This is the next type of question that they love asking in the exam, and that is to draw up your own diagram and to use your diagram to simplify the trig. So let's look at how do we identify sums like these. Given that tan x is equal to square root 5, where x is elements of between 90 and 270 degrees. And then they also give square root 2 times cos y plus 1 is equal to 0, where sine y is bigger than 0. That's actually where sine y is positive. In English, that is what bigger than 0 means. Then they say, determine the following using relevant diagrams. Now, very important in this specific sum, you have two different angles. The first ratio that they give here, you have an angle of x. In the second ratio that they give, you have an angle of y. Now, if you have to draw up diagrams, every single angle will have its own diagram. So you can't just go and draw up one diagram and simplify the x ratio and the y ratio with the same diagram. Each one needs its own diagram. So we're going to start with the tan one. I'm going to write that down. Tan x, sorry for that. Tan x is equal to square root 5. And they also gave us a restriction for x. They say that x is between 90 and 270. So I have to use this information to draw up my first diagram. Now, before you start drawing the diagram, you first need to go write down what is actually given here. Tan x is square root 5 over 1. I know that square root 5 over 1, that tan is y over x. So they are actually giving me a y value and they are giving me an x value. How do I know tan is y over x? Because that's the ratio for the tangent trig ratio. Right, so next step, I draw up my cast diagram. And now I'm going to check the signs. In the first one here, they say tan x is positive square root 5 over 1. So I need to go and tick off in my cast diagram where will tan be positive. So I take a color pen here and I say quadrant 1 and quadrant 3. I know in quadrant 1 and in quadrant 3, the tangent ratio will be positive. Then I go to my second restriction, and they say there, just going to use a different color here, x must lie between 90 and 270 degrees. Now, if you have to go measure that on the cast diagram, I know that 90 is there, 180 is there, and 270 is there. So I know that between 90 and 270 will cover these two quadrants here. So I tick them because both of them will cover 90 to 270. And now if you look at your cast diagram, the quadrant where you have two ticks, that will be the quadrant where you go draw up your diagram in. So slowly but surely I'm getting there. I draw my cast diagram again, and I know that I am going to draw a diagram in the third quadrant. Now, very, very important because you really make mistakes here. When you draw the diagram in the quadrant, you always start at the 0, 0 mark. You will go out from there, and perpendicular to the x-axis, you will come down. A lot of you draw weird kinds of triangles in there. Please remember, your radius must come out of your 0, 0 line. From that line, you go up or down to your x-axis to finish your diagram. Right, so that I know is it's definitely going to look like that. And now I'm going to use this information. They say that y is square root 5 and x is 1. So, I know that y is square root 5 and I know that x is 1. So you go fill that in. Your y's, square root 5, your x is 1. Now, very, very important. When you go write in those values on your diagram, you need to go check now, are your signs correct? If you look at the x values here, from 0 to the left-hand side of 0, I have negative x values. So that minus need to go with the 1, because you are actually on the negative side of your y-axis. Then here, if everything below the x-axis has negative y values, so you also need to add a negative in front of your square root 5. And this is where they always catch you out, is with these signs. So when you go write down your values in your diagram, please check, am I in the right quadrant? Am I using the correct sign for the correct number line that is presented there? So be careful. The only other thing that I need now in this diagram is my radius. I have my x, I have my y, I need my radius. And luckily we know that that is a perpendicular triangle. And perpendicular triangles, how do we solve them? Pythagoras. And this is where Pythagoras comes in. If I want to get to the hypotenuse, or the radius in this case, I'll say radius squared is equal to minus square root 5 squared plus minus 1 squared. If I simplify that, I get 5 plus 1, which gives me 6, and my radius then is square root 6. Remember, if you take the square root in any equation, you normally get a plus minus there, but your radius can never be negative, so we don't put that in. I know that my radius will be positive, so we don't put the negative in there. Right, so I have my y value, I have my x value, and I have my radius. So my first diagram is done, and I have all the different variables that I need to solve my trig ratio. Let's look at the first question. What did they want us to solve here? They said sine squared x over cos squared y. Okay, that's a problem. I have the diagram for x, but I don't have the diagram for y. So I still need to go set that up as well. So let's look. What did they give for y? They gave square root 2 cos y. I'm just going to write that down for us here. I'm going to use a different color. Square root 2 cos y, I think it was plus 1 equal to 0. Let's just go check quickly. Plus 1 equal to 0, and sine y must be bigger than 0. Sine y must be bigger than 0, and I know sine must be positive. That's what they mean there. Okay, so I need to isolate my trig ratio so that I can get to values. So I'm going to keep my cos square root 2 there. Take the 1 to the other side, it becomes minus 1. I divide by square root 2. I get cos y is equal to minus 1 over square root 2. And I also know that cos, the ratio for cos is x over r. So I write down my cos diagram, and I'm quickly going to tick off my quadrants. Where will cos be negative? Cos will be negative in the second and in the third quadrant. Then my second tick. Where will sine be positive? In the first and in the second quadrant. So I know that my diagram must be drawn in my second quadrant. So I draw up my cos diagram. From the 0, 0, the radius up and down perpendicular to the x-axis. I know that x is negative 1. I know that my radius is square root 2. Check the signs. On the left-hand side of your y-axis, yes, I have a negative. Square root 2, this is a radius or an hypotenuse. It must be positive, and that is definitely positive. So the only thing that I still need to find before I can solve my problem is to find my y value. And you're going to do exactly the same thing. Y squared is now your hypotenuse squared minus one of your right-sided values. You get 2 minus 1, so you get 1, and y is then 1. So your value there for y is 1. And now both of my diagrams are finished, and now only can I start with the question. Let's go up again. What do they want us to find the answer for? Sine squared x over cos squared y. Sine squared x over cos squared y. Now I know that sine is y over r. I know that cos is x over r. So I'm going to use those ratios. Okay. In the first one, I need to go back to my diagram for x and then go check the y over r for that one. So I go up, y over r, I have y there over r, so it's minus square root 5, and my radius there was square root 6, so I go put that back in, square root 5 over square root 6, and I square that. Then cos squared y, so I have to go to the diagram with the y value, which is this one, and it's x over r. My x is negative 1, my radius is square root 2. Negative 1 over square root 2, and I square all of that. Then I simplify, that becomes 5 over 6, and that becomes 1 over 2, and I times and tip, and I get for my final answer 5 over 3. Very nice answer, simplifies very neatly. Just remember, be careful. If they talk about the x angle, go to the x's diagram. If they talk about the y angle, go to the y's diagram and then use the specific ratio for that specific diagram that you used. Okay, going on to the next question. It's exactly the same question. Now they want you to simplify cos 180 plus x. Now luckily, most of the work is already done. Okay, I have my two diagrams. Now I just need to simplify this reduction formula and then go check what the ratios are in my specific diagram. So I have cos 180 plus x. 180 plus x is in my third quadrant. I know that cos is negative there, so this simplifies to minus cos x. And you want to look at your x diagram, so I'm going to go back to my question. My x diagram, there it is, and I want cos x, and cos is x over r. And my x here is negative 1, and my radius was square root 6. So I go back. I have negative 1 over square root 6. If I simplify that, I get 1 over square root 6. So again, you use the diagram for every single value that they want you to find. Right, moving on to the next question. They say here, if sine x minus square root 3 is equal to 0, and cos x is smaller than 0. So what you need to see here is they are using the same angle. Okay, that helps us a lot. Find the following using a relevant diagram. So you definitely have to draw up a diagram, and they want you to find the value of cos squared x. Now you can't start immediately and say cos squared x is that. You first need to draw up the diagram, then check the signs, then go and find your ratios for cos squared x. So let's start off with 2 sine x minus square root 3. So I have 2 sine x. I'm going to take the square root 3 to the other side, and I'm going to divide by 2 everywhere. Remember, we need the trig ratio alone on the left-hand side. We need to isolate it. So I know that sine x is equal to square root 3 over 2. And I also know that sine is y over r. Then, what else did they give? They said that cos x is smaller than 0, which actually means cos x is negative. So, let's go tick off in our cos diagram. Where will cos be negative? Second and fourth. Where will sine be positive? First and second. So where will my diagram be drawn in? Yes, in my second quadrant. So I draw up my diagram. My y is square root 3. My radius is 2. I need to find my x value. But this is a very famous triangle, because if you look at that ratios, you have square root 3, 2, and I can immediately say that my x will be 1. Because as soon as you have your square root 3 and your 2 in the right positions, then you know it's that magic triangle for special angles. So if you can go work it out, but I'm already going to say that my x there is 1. Be careful, it's not 1. It's on the left-hand side of your y-axis. So in this case, your x is negative 1. Right. They want to know, what is cos squared x? I know that cos is x over r. I know that my x here is negative 1. I know that my radius is 2. I square that, and my answer, 1 over 4. Very nice question, very simple. Let's move on to 4.2. 4.2 says, find the following using a relevant diagram, exactly the same as the previous one. Again, you are going to use the diagram that you just used to find the values of sine 180 plus x, tan 360 minus x. Now, as soon as they give you reduction formula, you have to reduce it first and then go simplify. So I have to check my cos diagram again. If sine and tan is positive in that specific quadrants that they are talking about. So 180 plus, that is the third quadrant. Is sine positive or negative in the third quadrant? It's definitely negative, so negative sine x. Then 360 minus is in the fourth quadrant. Is tan positive or negative in the fourth quadrant? Negative. Right, so now I can write in my ratios. I know that sine is y over r, and I know that tan is y over x. So I have to go back to my diagram quickly, y over r. Y over r is square root 3 over 2. And I have 2 over 1 there, and that's minus 1. If you simplify that, minus square root 3 over 2 over 2, and you're going to times and tip there, times and tip, and you get minus square root 3 over 4. Very nice. Use this, exactly the same diagram to simplify for that specific reduction formula given. 4.3, again, exactly the same thing. I'm going to use exactly the same diagram again. So now they say, please simplify cos 90 minus x times cos 30. Okay, this needs to jump out to you, and you need to know, yes, that is co-functions. 90 minus, cos changes to sine, sine changes to cos. So I have cos that changes to sine, 90 minus is the first quadrant, and everything is positive there, cos 30. Now I know that 30 is a special angle, so I'm quickly going to draw up my magic triangles here. You have 1, 2, square root 3, and cos for 30 is x over r, so that is square root 3 over 2. So the only thing that I need to go find from my diagram is sine, and I know that sine is y over r. So let's go check. Y over r, square root 3 over 2. Square root 3 over 2, that gets multiplied, so you get 3 over 4 as an answer for that specific question. Right, let's move on. Now we have question 5. Question 5 says, if tan A is equal to P over K, okay, this is funny because they don't give any values, but don't stress, variables are exactly the same as numbers. You can just see numbers instead of P over K. And A is smaller than 90. Find the following in terms of P and K. Right, they want you to find sine A. Now, you are definitely going to use a diagram here because there's no way that you can use your calculator with variables. I mean, P over K, you can't put that into your calculator and get an answer for that. So I'm going to write down tan A is P over K. And I also know that tan is y over x. Then they said angle A is less than 90. What does that mean? Angle A is less than 90. It means that angle A is an acute angle. So if I have to go check my quadrants, where is the only space on that cast diagram that you can have an acute angle? Your first quadrant. That is the only quadrant where you will have an acute angle if it's a positive angle. So then the only thing else that I need to go check is where is tan positive, because I don't see a negative there. So I just need to go tick off where will tan be positive in the first and in the third quadrant. So I know that my diagram will be drawn in my first quadrant. So I again quickly draw up my cast diagram, put my diagram in, that's 90 degrees. My y here is now P, and my x now is K. Before you go on, check your signs. Okay, my y values are positive because I'm above the x-axis, so that's fine. And my x values are on the right of the y-axis, so it must be positive, so my values are fine. So the only thing I still need is my radius. And again, you are going to use Pythagoras. So you have b squared plus k squared will give you radius squared. So the radius then is square root p squared plus k squared. And now let's go to the question. Find sine A. Sine A, I know that sine is y over r. my y in my diagram is P, and my radius in my diagram, I just found it, is square root P squared plus K squared. So you do it exactly the same. Even though you don't have values, it's exactly the same steps that you take. Let's look at the next question. Use the exact same diagram to determine 1 over k times cos A. So 1 over k will definitely stay the same. I know that cos is x over r. So I need to go back to my diagram and check what's x over r there. X is k and r is p squared plus k squared. So I have 1 over k times k over square root p squared plus k squared. And if you simplify that, you have a k and a k there. So your answer here, 1 over the square root of p squared plus k squared. Very nice and easy. Moving on to question number 6. Question number 6 says, cos P is equal to minus 3 over 4 and sine P is bigger than 0. Use a sketch, no calculator, to find the value of that. Okay, for 4 marks, most of those marks will actually go into your diagram sketching. I think you will probably only get 1 mark for simplifying the final answer. So let's see, they gave us cos P here, and they said that's minus 3 over 4. And I know that cos is x over r. They also said that sine P is bigger than 0. I have P and P, so that helps a lot. So sine, where is sine positive? So I know that sine is positive in the first and in the second quadrant. I know that cos is negative in the second and the third quadrant. So my diagram will be drawn in my second quadrant. My x is negative 3. My radius is 4. I need to find my y value. See, you do exactly the same thing every single time. So your y squared is now your radius squared minus your side squared, which gives you 16 minus 9 . So you get 7 and square root 7 will be your y value. So you will fill that in, square root 7 for your y. And the question was, find the value of square root 7, I'm going to write this down for you, square root 7 times cos 90 plus p. 90 plus p. Now before I start substituting anything, I need to first simplify this, because that 90 plus tells me cofunction. Be careful. The cofunction 90 plus p is in the second quadrant, and cos is negative in the second quadrant, so this becomes negative sine p. So you have square root 7 minus sine p. I know that sine is y over r. So I go check in my diagram. What is my y? That's square root 7. And what is r? 4. So that's square root 7 over 4. And you simplify, and there's your answer. Exactly the same as all the previous questions. Finally, we move to the next kind of trig question. And that is where they want you to prove the left equal to the right by using identities. So let's look at question 7.1. Prove that sine A plus cos A, everything squared, plus sine A minus cos A, everything squared, is equal to 2. This proof tells me that I need to prove that the left-hand side is equal to the right-hand side. In this case, I will definitely start with my left-hand side because that looks complex. So you need to simplify the complex left-hand side to get to 2. So let's see if we can do that. Just going to write everything down again quickly. Right, I know if I have to simplify and I have brackets with squares in it, I have to use FOIL. Okay, that's the only way you can simplify any algebraic expression which has brackets squared. So I'm going to apply the same rules in algebra, but now to my sines and coses. So if I FOIL this out, I get sine squared A plus 2 sine A cos A for a middle term plus cos squared A. Then for my second bracket, I get sine squared A minus 2 sine A cos A plus cos squared A. So I multiplied everything out. Now I'm going to add and subtract all my like terms. So I have plus 2 sine A cos A and I have a minus 1. So those two cancel out. Then I have left 2 sine squared A plus 2 cos squared A. This must ring a bell. Sine squared A plus cos squared A, I know that that is an identity which gives me 1. But I have a problem here. I have a coefficient of 2 in front of every single term. So I take out a highest common factor. What is left? And 2 times 1 is 2, and there is my right-hand side. Very nice question. Let's move to question 7.2. 7.2 says, prove that whole difficult left-hand side is equal to 2 over sine theta. So I'm definitely going to start with the left-hand side again. Sine theta, 1 plus cos theta, plus 1 plus cos theta over sine theta. Now I can't add them because they are definitely not like terms. But I see fractions there. And if I see fractions, I know that I have to use an LCD, highest common denominator. So let's quickly go right down the highest common denominator for both of these terms. I have 1 plus cos theta times sine theta. Remember that your lowest common denominator must represent every single denominator that occurs in your expression. So, what do I need in this denominator to make it look like that one? I need a sine theta. So sine theta is multiplied by the top. So you get sine squared theta at the top. What do I need in this denominator to make it look like the big one? 1 plus cos theta, which is then multiplied by the top, which is the same bracket. So I'm just going to say 1 plus cos theta squared. Okay, let's start simplifying at the top. You get sine squared theta plus 1 plus 2 cos theta plus cos squared theta. Let's just quickly go back to the top. I need to find 2 over sine theta. Okay, so I can still simplify a lot here to get to that. But a very nice tip that I can give you here. If you look at your right-hand side, you want a sine theta at the bottom. And if you look at your denominators here, you have a sine theta there at the bottom. So it will not help you to now go multiply the sine theta into the bracket, because you already have that there. And that's part of the answer. So if I were you, please don't multiply in. Let's just simplify the top first. I know that sine squared theta plus cos squared theta is 1. So that one plus that one simplifies to 1 plus another 1 plus 2 cos theta. And I have 1 plus cos theta in a bracket and sine theta in a bracket. Simplify further, I get 2 plus 2 cos theta. Same thing. And at the top now, I'm going to take out a highest common factor of 2, which leaves me with 1 plus cos theta. And at the bottom, I have exactly the same bracket. 1 plus cos theta. And again, a sine theta. I have one term at the top, one term at the bottom, so now I can start cancelling out. 1 plus cos theta over 1 plus cos theta, so my answer 2 over sine theta, and that is definitely my right hand side. Yes. Very nice question. 7.3, it says there, cos 180, and it gives a lot of reduction formula there on the left hand side, and they say, prove that that is equal to 1 minus sine squared a. Okay, so let's start with the left hand side. I have cos 180 minus a, I'm just going to write everything down again, plus a, I see reduction formula, so this is actually quite easy. So I just need to check my quadrants to check for the signs. Sine squared a plus cos squared a, that immediately changes to 1. So you can actually just write 1 there, it's not necessary to write that whole identity out. Now I'm going to write down my cos diagram and check for my signs. 180 minus theta is in the second quadrant, and cos is negative there, so that changes to minus cos a. Tan 180 plus, tan is positive there, so that is tan a. 360 minus, sine is negative there, so that becomes minus sine a over tan squared a. 1 tan cancels out with 1 at the bottom, and minus and a minus becomes a plus, so you have cos a at the top as sine a at the top, and at the bottom you have a tan a. Let's just go to the right hand side. What do I need to find? 1 minus sine squared a. Okay, I'm not nearly there, so I can still go on and simplify as far as I possibly can. Cos a over sine a. I know that tan is also the same as saying sine a over cos a. And normally I teach my learners to go and change that division sign into a division line into a division sign, which makes it better to simplify, and it even looks easier if you do it that way. I change it to a division sign, and it's sine a over cos A. Then you are going to tip and times. Cos A is now at the top, sin A is now at the bottom. I have one sin A at the top, at the bottom, and one sin A at the top. So what is left? Cos squared A. Cos A times cos A is cos squared A. Okay, so it's simplified to cos squared A. But look at the answer. They want 1 minus sine squared A. And this is where you need to know that your identity comes into play. Sine squared A plus cos squared A is equal to 1. So if I want cos squared A alone on the left-hand side, I'm going to take the sine to the other side. So that is the same as saying 1 minus sine squared A. And there is your right-hand side. Right, let's move on to the next question. Question 7.4, again, prove that. So again, I'm going to work with identities. I'm going to try and get the left-hand side equal to the right-hand side. So let's see what they ask here. Tan theta plus 1, everything squared, plus tan theta minus 1, everything squared, should eventually give you 2 over cos squared theta. I'm going to start with my left-hand side since that looks more complex. And it's squared and it's squared. Now I said to you, whenever you have brackets squared in algebra or in trigonometry and you have to go and simplify, you are going to multiply everything out. It's basically using the distributive law, and we also call it FOIL. So I'm going to FOIL all the brackets out here. So I have tan squared theta plus 2 tan theta plus 1. And the second bracket gives me tan squared theta minus 2 tan theta plus 1. And now I'm just going to add and subtract my like terms. I have plus 2 tan theta and minus 2 tan theta. So they cancel each other out. Then I get 2 tan squared theta, because 1 plus 1 is 2, plus 2. 1 plus 1 is 2. And then I'm going to take out a highest common factor. So I have tan squared theta plus 1. And let's go check my right-hand side. I have no idea how I'm going to get to that. But let's just keep on simplifying. Don't stress. Eventually you will get to your answer. Tan, I know that tan is also sine squared theta over cos squared theta plus 1. Now I have a fraction plus a constant. As soon as you add or subtract fractions from one another, what do we need? An LCD, lowest common denominator. So I leave the 2 outside and I get a lowest common denominator. What do I need in this denominator to make it look like that one? Well, nothing. So the top just stays the same. What do I need in that denominator to make it look like that one? A cos squared theta. So cos squared theta is multiplied by the top. So you get cos squared theta there. And I know that sine squared theta plus cos squared theta is 1. So that cancels out. It becomes 1 over cos squared theta. And your final answer, 2 over cos squared theta. Let's just go check the right-hand side, and that is exactly what we have. So that's equal to the right-hand side. So these 4 sums, all of them, were all questions on identities. How do you prove the left-hand side equal to the right-hand side? So yes, that is it. That's all that we have time for today. I really hope that we could sort out all of your misconceptions and your problems. And I hope that you can now also see that trig is actually a very nice and exciting section. Good luck for the exam, and I'll see you again.